Thanks everybody for joining. I'm going to be talking about Informix SQL performance tuning tips. Learn how to improve your Informix SQL statements to optimize performance in your Informix database. About myself, my company Integrated Data Consulting. I do specifically Informix consulting services. Overview, we'll talk about using SQL Statement Cache, review reads on tables, tracing SQL in Informix, using Informix HQ SQL tuning for tracing, SQEXPLAIN plans and tuning, use of PDQ and non-PDQ, and talk about some new features with temp tables. Using SQL Statement Cache, you can look at that by running onstat-g SSC. When you look through this, look at a lot of the SQLs with a large number of executions. Just kind of looking at the SQLs, if you kind of dig down into them, saving even a second on a SQL statement that it's executed, for example, a million times can make a big difference in performance. And there's also some new features with 1410 for statement cache that we'll talk about. Here's an output of SQL Statement Cache. It gives you the statement, gives you the cache information at the top, the pools, the current size. Then for each of the SQL statements, it tells you how many times SQL's been ran. And then gives also the SQL statement. So there's some of the statement cache enhancements. There's new sysmaster tables. They can coincide with the onstat-g SSC. Here's some of the links that you can go to look at. For example, you can invalidate specific statements in the statement cache. You can also lock query plans in the statement cache. You can also dump query plans from the statement cache. There's a new onConfig parameter, stmt_cache_query_plan. 0 disables it and 1 enables it. It's disabled by default. It will consume more of your statement cache size. And the query plan is viewable in sysmaster SQL CLM query plan column. You can use a statement cache query plan to enable SQL statement caches to hold query plans for each of the cache statements. Here's a row that shows the result of from the table. So if you do a select from sysmaster, syslem, you'll get the filing information, number of hits, flags, whether it's locked or not, the database that it's using, the user ID. And then now on the next page, it'll also, let me go back a page here. Yeah, here's the page. So here it also then gives you the statement string, and then it gives you the query plan that it used. To invalidate a statement, you run an update statement where it sets the valid equals 0, where an ID equals value. And then you can validate it by running the onstat-g SSC. You can look at the flag value that it shows. It'll show a DF next to it, saying that, showing that it's invalidated. Lock a statement. You can again run an update statement, setting lock equal 1 where the unique ID equals the value. And again, you can validate it by running onstat-g SSC and look for the flag showing FL for it being locked. Next, we're going to talk about review number of reads on tables and indexes. Use the table sysptprof to look at the buffer reads, page reads, and sequential scans on a table. And here's a query, the query that you can use to run that, to get that information. Here's some example of some reads on some tables, and you want to sometimes look at what tables or indexes have the most buffer reads or page reads, because there may be more optimizations that you can do. They may be doing a lot of sequential scans, and that's why your buffer reads or page reads are high. So one thing you can do by looking at that, you can go back to your queries and look to see maybe adding new indexes could help improve performance. So in this case, we added a new index, and by doing that, it reduced the number of buffer reads by a substantial amount. The top part is the original number of buffer reads, and then the bottom part, the next one, shows how the amount of buffer reads that it did after the index. So by adding the index, it made a big difference. Tracing SQL and Informix. There are more ways to find information to tune Informix utilizing the state tracing of SQL. One, you enable the onConfig parameter SQL trace. You can use the SQL admin API to also turn on tracing, and also in Informix HQ, you can enable tracing. So here in the SQL trace, in the onConfig parameter, you have a level of low, medium, and high, the number of traces that you want to have, the size of each trace buffer. The mode is either global for all or a specific user. And here below, here's an example of the SQL trace from the onConfig. So we've set it the level to low, the number of traces of 1,000, the size 2K, and the mode is for global. So it allows me to trace the last 1,000 statements of the instance. Improving SQL tracing with SQL admin API in Informix, you can use these commands to manage SQL tracing of your database. So you can dynamically change the values by using the set SQL tracing database, either add, clear, list, remove. You can also suspend and resume tracing without deallocating the resources at any time. Here's how to enable tracing through the sysadmin database by running the following commands. Say execute a function with task, set the SQL tracing on, your number of traces, your buffer, trace types, low, medium, or high, and then, for example, global or user. To validate that your tracing is turned on, you can run onstat-g HIS. This prints out information about the SQL trace configuration parameter and the different SQLs that have been ran since it was turned on. So if you ran onset-GHIS, it'll give you the trace level, the mode, the number of traces, current statement ID, your trace buffer size, the duration of the buffer, trace flags, and the control block. Also, then you'll get information about the SQL statement, how many rows it read, the cost, and then it'll also give the finish time and the runtime of the query. And whether it's for example, select, update, or delete. You also get some more information on the page reads, your buffer reads, your buffer writes, your locks, total execution, and how long it took it, and how many rows were returned, and if there was any SQL error. So it gives a lot of detailed information. You can also get the information on the tracing through the SysSQL trace table in the SysMaster database. For example, here's a query, do a select count from the SysSQL trace where the SQL total time is greater than, in this case, 2. So you'll be able to see it a little easier than in the onstat-GHIS information. Another useful table is a SysSQL trace iteration, which gives you the information in the form of an iteration tree for each of the SQLs. It allows you to identify which part of the query plan took the most time to run. So again, you can run the following SQL statement to get the SQL for the ones that have a higher runtime, greater than half a second, for example. So here's the query that you would run to get that information. Here's what the SysSQL trace information shows. Gives you the SQL ID. That's like just identifies each SQL statement. The address, the session ID, the user ID, the statement type here would be a select, your finish time and your begin time, the runtime, number of page reads and buffer reads. Also gives a lot more information, lock writes, sorts, average time. There's a lot of information that you can dive into. And give you some more SQL errors, ISAM errors, gives a statement that was ran. You can also save the history of the SQL trace information. Note that with caution that when using it, it can use up a lot of space. In the scheduler, there's a new task called Save SQL Trace. And then the information is saved in the following tables in the sysadmin database. The mon SysSQL trace, the trace info, and iteration. Here's an alternative to saving all the tracing information, like shown on the previous slide. When I first started using the SQL tracing and trying to save the information, we created its own DB space to put the trace information in, but there was so much data coming through that we filled up 20 gig of DB space from the tracing in like less than a day. So an alternative, instead of saving all tracing, you can create a task which saves SQL tracing information for SQLs that have a runtime, for example, like greater than 10 seconds. This will allow you to still trace information, but only show the real long running queries that you really care about. You don't care about if a SQL statement took 0.11 seconds to run. You want to see the long running ones. And you can it filters out a lot more of the information that's not needed. So one thing I did was I created a table to save the SQL tracing information. Again, put it in its own DB space so that if it filled up, it's not going to affect any other processes. I created a raw table. So again, it wouldn't be logging, inserting all this information. Now, if you have replication and so forth running, you'd want to create it with just a regular table instead. Here's the information that you need for creating this task in the sysadmin database. Now we're going to look at using Informix HQ, using Informix HQ to look at SQL tracing. Here's a screen that gives you the information, shows the status, it's enabled, the mode is global, levels low, it shows number of traces, shows your trace size. So again, tells you that your start time, your duration, total number of sequels, and then it also will give you information on the different types of statements, whether it's a create index, a delete, a select, and an insert. And it'll give you the average runtime, the max runtime, so you can kind of dig down and see where there may be performance issues in each of the types of statements. You can also use in Informix HQ system reports. They have a lot of information on there, lock lists, locks per tables, resources, session activities, slowest SQL statements, SQL caches, most buffer activity, most memory, table extents, update statistics, and so forth. Again, all these can help with reducing your runtimes of your queries and programs. Here's some options available with SetExPLAIN. You can set the optimizer directives to avoid execute. So let's say you want to get the explain plan of a update statement, but you don't want to actually execute the update statement. So you can go ahead and set avoid execute. So it'll give you the explain plan, but not actually changing the data. Here's an example, set explain on avoid execute, and then give you the SQL statement. Here's some of the SQEXPLAIN enhancements over the years. You can turn on and off explain stats through the onConfig parameter explain stat. You can also set it with the following statistics or statement, set explain statistics. When it's enabled, the inclusion of the query statistics section in the explain plan output will show. The plan, it'll show the queries plan, the estimated number of rows, and the actual number of rows returned. Here's a query that shows the explain plan information. So the top part, you have your select statements, your estimated costs, the indexes that it used, and then down at the bottom, it'll give more information about what the number of rows it was processed, number of rows it reads, rows it scans, and the estimated cost. You can also use dynamic set explain, so you can dynamically set explain on for a session by running on mode-Y and the session ID and 0 for off and 1 for on. It's output to a file called SQEXPLAIN.out with the session ID. Within Informix 11, there was some new features and additional value it added to. So it gives explain without statistics for a session. It displays only the query plan. Also, it can be also you can specify the file name and the directory that you want the explain output to be sent to. So it's a great feature to allow you to see that the statement, SQL statements being executed for the explain plan for each of the SQL statements. Be careful though, don't just leave this, turn this on and forget about it, because it'll create a large file in a short amount of time that could fill up a file system. Also, you can add set explain on before the statement you want to examine. So you can specify the directory that, again, you want it to go to by doing set explain file to a file name. And to review the set explain output in Unix, the file name would be SQEXPLAIN.out. It'll be generated in the directory that you ran it query from. Again, for Windows, you look for a file name, user.out on the directory of the Unix server. So set explain output. There's different sections in set explain output. You have a query which displays the execution query and indicates whether set optimization was set to low or high. The directives were filed if there's any directives used for the query. The estimated costs of the amount of work of the query. The number doesn't always translate into time. You only compare the same type of queries, not every different ones. And then also gives you the estimated number of rows returned. It's estimated based on the number of rows returned based on the information from the system catalog tables. You also have a number list, which gives the order in which the tables are accessed, followed by the access method, either in index or sequential scan. Again, the index keys will show the columns used as the filters in the index, and the query stats enabled by the parameter explains stat. Next, we're going to talk about examples of explain plans. Following slides will show tuning of SQL based on following scenarios: functions causing an index not to be used, criteria from views causing sequential scans, using in clauses for sequential scans, use of directives, use of substrings in queries, use of functions in queries, and using a better index, creation of a new index. So in this case, we had a query that we were running and it was doing a sequential scan. Even though when we looked at the indexes, we saw for this table, the tables that was running, that they had indexes on those columns. But the problem is that when we were looking, when you sometimes you have to break down the query and look to see what's the query is doing. And in this case, we were doing an upper on a column. And usually, a lot of times when you do any types of functions in queries, you have to watch, because a lot of times they won't use the indexes. They'll do more sequential scans. And that's what happened in this case. So what we were able to do with the query was, in this case, all the data was in uppercase, so we didn't have to really use the upper function. So we were able to remove the upper function, and now you can see we're using indexes. Another way for that, if you did still need to do uppercase, you can add a function which converts the characters to all uppercase and change the index to include the use of the function. So here we created a function where we uppercase a certain column, and then we added that function into the create index statement. And that also helped improve performance tremendously. Here's an example of criteria used to select from views that cause sequential scans. So again, looking at this query, we looked at it, and one thing I do sometimes when I see a query, when you see sequential scans, I start commenting out some of the where clauses until I see what part of the query is actually giving us the problem. So in this case, you can see here, we're doing a sequential scan on the table, even though we have indexes on the columns in the where clauses. So in this case, again, like I kind of mentioned before in the previous slide, I went ahead here and I commented out the on-hand quantity. Once I commented that out, all of a sudden the query ran fast and used the indexes correctly. So in this case, we were able to in the program, we were actually able to put functionality in the program to handle that case. Here's a view used in a query that caused performance to do sequential scan. So here was a view, creating a view. And this was the one from the previous slide, the on-hand quantity. Using an in clause in sequential scans. So here is a SQL statement where they were looking for a value in each of these different columns. So it was doing a sequential scan on that. So what we did with this, we actually added some new indexes on some of the columns, and then we changed the query to use an or instead of an in to improve the query performance. So here's the change that we made. So instead of having the number be the first part of the where clause, we actually changed it around with the values and the columns and adding the new indexes. So now you can see in the query plan that it's using all the indexes. And the runtime now, instead of a few seconds, was less than a second to run. Here's a case of using directives for queries. Again, here is a large SQL statement. We had an estimated cost of 57,000, but it was taking a long time to run. So it did have some indexes in here on columns, but the query was still slow. So we tried multiple ways to get it to work, but the only way we're able to get it, sometimes queries, you can't get it to do what you want it to do. So that's why you use the order directives. So in this case, we wanted the query to be ran in the order of what the from clause of the tables. So in that case, it helped improve performance. Now, sometimes the cost, even though it showed the original cost was lower than the cost after the ordered index, it's the index, the ordered directive made the query much faster. And here's what it shows that doing that, now we're using the correct index to run the query faster. And here's another case of use substrings for the best index not used. So here we have in the bold, we had a part of the where clause was causing it to not use the best index. So what we did, we changed it to use matches on that to get the query, get the index the way to use the correct index we want. And then here's also another select using of functions that cause a specific index to not be used. So for example, this query, the customer, they were running this query and it would take 20 minutes to run every day. So when we looked at tuning it, I went and identified that they were using the date function, which was causing it to use an index or not use an index. By using changing it to use the extend of the date, it actually made the query run a lot quicker. So now you can see here we're using the indexes. Here's another query, resolution to use functions and queries. Again, this is with a date time function. Here's the original cost was 50 over 500,000. And here's part of the index path that it shows from the previous query. And then here's the use of a better index. Again, it wasn't using the best index that it could use. By adding a new index, now it was running a lot quicker. Now another part, this is one thing I see a lot of is the way people use subqueries. And a lot of times with subqueries, they tend to slow down the queries a lot. So here, for example, is a query we're selecting from a table where the criteria, and then we're doing a subselect on the bottom part here. So what we did is we improved the query performance by adding the bottom part here, the and doc number equals our doc number. So by adding that helped improve the query of the subquery tremendous a lot. Here's some more methods to improve SQL performance. Use multi-index scans, utilize temp tables when you have a large in clause, utilize PDQ priority, and utilize DS non-PDQ mem. So with multi-index scans, if you have a query that's has multiple criteria in the where clause you have with those columns, the optimizer can utilize multiple indexes at once to improve the query performance. So in this case, when I was working a query with it, trying to find out why it was taking so long, because it was doing a sequential scan. I looked at, again, the information from the SQEXPLAIN output. And then I looked at the indexes that were on the table, the current indexes. And when I looked at the query, I noticed that there was one of the columns that didn't have an index. So I then went ahead, created that index, and then the query ran quickly. So and here is the new part of the index that we added. And now it took less than a couple seconds. Utilizing PDQ priority for DSS queries. If you have large fragmented tables that you need to get better performance with, you can utilize the PDQ priority so it can uh, give you maximum threads based on your fragmentations. Utilizing DS9 PDQ query mem. This onConfig is a powerful tool. Setting this query correctly can improve the performance of your non-PDQ queries, which are pretty much probably most of your queries. This allows you to perform sorts in memory versus disk. To correctly set it, you need to set the DS total memory to a value and then set the DS non-PDQ query mem to up to 25% of it. Here's an example of using DS non-PDQ query mem. We set it equal to 50,000, and here you'll see down here it uses the sort mem buff in the query statistics. So here is a case, again, shows the sort memory buff. In one case, at a client, by increasing the DS9 query mem from 128, which is the default, to 50,000, the specific query went from 2.5 seconds down to 0.25 seconds. And also the waiting on IO from top went from 2% to basically 0. So it's a very powerful onConfig parameter to use. DB space temp changed. Now you can have temp spaces with different page sizes. So there's a new SMI table. I'm not going to try to pronounce that. Such a long table name, long name, but it contains information about each of the session's temp space usage for both implicit and explicit temp tables. So the output from this, you can see that the select from the table gives us this session ID, the partition in the table it's using, and how many pages it's allocating. So in summary, talked about using SQL Statement Cache, review reads on tables, tracing SQL in Informix, Informix HQ SQL tracing, SQL explain plans tuning, use of PDQ and non-PDQ, and new temp DB space functionality. And that's it. Any questions? I do have for 2 questions. I have one more thing to talk about. The next upcoming IAG Tech Talk is on May 25th at 2 p.m. It's by IBM with an Informix roadmap. It's going to talk about a brief overview regarding things that they're working on, including covering FC9 and FC10 fix packs for 14.10.
If you have any questions, I'll unmute everybody and they can ask questions of Jeff. You should be able to unmute yourself now if you'd like to ask a question. I'd like to thank you all for attending since I've not seen anybody posting anything or chat or seeming to unmute themselves. Jeff, thank you for the day and the time that you've given. Thank you for all of our attendees for being here. And remember, we do post all these out on our YouTube channel. Usually we'll get those up in a day or two. Thank you and have a nice day.
Thank you, everybody.
Thank you, Jeff.
Thank you, Jeff.